Hi Ma. In this video, we are going to discuss the question number 25 of exercise 6.5. The question is, show that the semi-vertical angle of the cone of the maximum volume and of given slant height is tan inverse of root 2. The question they have given that volume is maximum and slant height is given. That is the two important things we have to make a note, and we have to prove semi-vertical angle is tan inverse of root 2. As we have already discussed, the maximum whatever they have given, that is what we have to differentiate, and the given whatever they have given in the question, we have to equate to constant. But in this question, they have given the slant height as given. We just treat that slant height as a constant. That's it. Moving on to the question, as I already said, the given is slant height and volume is maximum. These 2 points is for your understanding, need not to be written in the answer. And this to prove part we will be writing, that is theta is equal to tan inverse of root 2. And we will be taking a cone ABCD. The naming is up to your convenient, and but stick on to that till your answer ends, and be careful while you just choose the part or whatever. Okay, and I'm using theta here to represent the semi-vertical angle. Our radius is BD and AD. Together AB is diameter, and BC and AC is the slant height of the cone. CD is the height of the cone. And I'm just taking a part from a cone, that is BDC. Since height and radius are perpendicular to each other, we can make use of the trigonometric ratios there. And for your understanding, that is for refreshing, wherever we have the theta, we'll be having this as adjacent, and opposite side will be opposite, and side which is opposite to the right angle will be hypotenuse. And cos theta, from the diagram we know the formula, adjacent by hypotenuse. So here adjacent side is height, opposite side is radius, hypotenuse is slant height. Substituting the corresponding values, so I'll be getting as h by L. Find what is height and radius using the trigonometric ratios. We will use that, as in the given question is tan, we have to make use of sine and cos. And taking sine for the angle, that is opposite by hypotenuse, substituting opposite as radius and hypotenuse is slant height, finding radius. Mark these two as two separate equations. I have used A and B for that. Write the volume formula, because in the question they have given volume is the maximum. So whatever they have mentioned in the maximum or minimum, we have to take that formula for differentiating. And substituting the equation A and B, that is for R it is L sin theta and H it is L cos theta. For R it is square, so we will be writing L sin theta the whole square and L cos theta. It will be L cube. In the given question, that it is given in the question that slant height is given, yeah, we will be taking that as a constant. While differentiating, we will not include that into the part differentiating factor. We'll just have it outside. Only sin theta, sin square theta and cos theta, we are going to differentiate both sides with respect to theta. Since we have two functions, that is sin theta and cos theta, we will be using UV method, UV dash plus VU dash. Anything you can take is U. You can either choose sin square theta as U or cos theta as U. The remaining will be V. That's it. And simplifying the terms, we get dV by d theta is pi L cube by 3, that is constant, so we don't want to worry about that. 2 sin theta cos square theta minus sin cube theta. Again differentiating on both sides with respect to theta, and using the product rules, we will be getting minus 4 sin square theta cos theta plus 2 cos cube theta minus 3 sin square theta cos theta. So simplifying the terms, we will be getting 2 cos cube theta minus 7 sin square theta cos theta. Okay. So the thing we have to prove is theta is tan inverse, whereas we get in terms of sine and cos. So what we are going to do is, because we cannot divide and multiply, as we have d square v by d theta square equal to. So whatever we multiply and divide in the right hand part, that will affect in the left hand part also. At the end it will be confusing. So the simple thing we can do is, we can take cos cube theta as common out, as we have sin square theta cos theta in the other term, the second term. When we take cos cube theta, and we will be dividing, so we'll be getting sin by cos as tan. There is a chance of getting tan. We are taking cos cube theta as common out. As we have 2 cos cube theta here, then cos cube theta and that will be getting cancelled. It will be 2. And sin square theta cos theta by cos cube theta, 1 cos theta will get cancelled. And for sin square theta by cos square theta, we'll have as tan square theta. We have found d square v by d theta square. To find theta, we will be equating the first derivative to 0, that is pi l cube by 3 into sin theta into 2 cos square theta minus sin square theta is equal to 0. I have taken the sin theta common, as we have 2 sin theta cos square theta minus sin cube theta. Both the terms we have sin. So I just chosen sin as common, and since it is in product, when we take to the 0, that is right side, that will also be 0. And taking minus sin square theta to the right side as positive. As we need tan, I am just taking the product cos square theta as a division, that will be tan square. And root 2, because taking the square root, will be getting tan theta is equal to root 2. Taking tan to the left side, that will be tan inverse of root 2 equal to theta. One part of the answer proving part is over. The other part, we have to show the volume is maximum. For that, in d square v by d theta square, we have cos and tan, but we have found tan value, we don't know the cos. For that, we are going to use the identity. In the equation 1, we have tan square theta value. So we are making use of the identity, that is 1 plus tan square theta is equal to secant square theta. After finding the secant square theta, using the reciprocal relation, we can find the cosine angle. That's it. Substitute in the second derivative. Check whether you are getting the positive or negative. Here, after cancelling the terms, we will be getting minus 4 pi L cube by 3 root 3, that is negative. So tan inverse of root 2 is a point of maxima, which implies volume is maximum. So we have expressed height and radius in terms of sine and cos, because in the question it is given as tan. We need sine and cos, because otherwise we cannot simplify that much easily. And given slant height, so we have treated L as the constant. As usual, finding the first derivative, second derivative, and equating the first derivative to 0, we can prove this answer. If you have any doubt, ask at any time. And I hope this will be helpful for you. Thank you.